All right, so this is going to be about capillary exchange. This is not in your textbook, okay, so just know that. Capillaries, if we go back to an earlier lecture, they are only made of the tunica interna layer. So remember, that's a single layer of simple squamous epithelial tissue. So exchange of materials in and out of the bloodstream at a capillary bed is going to happen really rapidly and easily. So exchange and movement, they are going to occur in 3 different ways that are all specific examples of passive transport. And if you go back to biology, you covered passive transport mechanisms, that just by definition that they are going to move materials from an area of high concentration to an area of low concentration. And as a result of that, the cell will not use energy in the form of ATP because the substance is going down its concentration gradient. So we'll start with diffusion, but we're also going to talk about filtration and osmosis. So diffusion, this is the most common or prevalent means of gas exchange. So if we kind of couch this as blood has left the left ventricle of the heart, it's gone out the aorta, it's oxygenated, it's going to take oxygen to all the tissues of our body. When it gets to, let's just say your toes, all right, in the capillary beds in your toes, oxygen is going to be in high concentration in the blood. So it's going to diffuse into the body tissues from a capillary. Carbon dioxide and waste products, those are in high concentration in your tissues, and so they are going to move from your tissues into the bloodstream, into the capillary. And then they'll enter the venous return to go back to the right side of the heart. Okay, so that then from the aspect of just simply carbon dioxide, that then when you exhale, you're getting rid of that as a waste product. Okay, so that's diffusion. Quick and easy oxygen into tissues, carbon dioxide out of tissues if we're talking about just various locations within the body. This will be one we come back to when we get to the respiratory system again. Then we have next filtration, and I had to cross out that word is there, just FYI. So blood pressure is going to increase when the heart contracts. Okay, this is going to force small particles out of the capillaries and into the tissues surrounding them, right? So when we look at this in general, I already mentioned that arteries are under high pressure, okay? And so at the arterial end of a capillary bed, blood pressure is going to be higher than it is at the venous end of the capillary bed, okay? So within the capillary itself, again, small particles are going to be forced into surrounding tissues just by being filtered, okay? And this says, as pressure decreases toward the venous region of the capillary beds, water and dissolved substances are going to move into the capillaries, okay? Hang on just a second. All right, I realized I needed to get closer to this particular picture. So again, at the arterial end, that's where filtration is going to occur. And then as the blood pressure drops in the capillary bed, then at the venous end, it mentions, again, in the blue on the right there, it says that water and dissolved substances can move into capillaries, so that's where they might get reabsorbed. And that's what that picture is showing. All right, and then as far as going back to biology, osmosis, if you remember that it is the net movement of water from where water is more concentrated to where water is less concentrated. And I inserted the word so there. You still can't really read that, but I just realized that was missing. So this says that blood in capillaries is going to have a higher concentration of solutes than does the surrounding interstitial fluid that bathes all of our tissues. So in theory, water should move into the capillaries from our tissues, from that interstitial fluid, by osmosis. But instead, blood pressure inside those capillaries is going to push water from the capillaries into the tissues, just because, again, that pressure is going to be exerted on that water, push it into the tissues. And so then when we get to the lymphatic system next, we're going to see that the lymphatic system is going to then return that water to the blood. And we'll talk about how that happens through our lymph vessels. All right, so this next section is going to be about blood pressure. Okay, so by definition, it says the force of blood pushing against the walls of blood vessels. That's what blood pressure is. It's normally going to refer to the pressure that's inside the major arteries, such as the aorta, and it's often measured with an instrument known as a sphygmomanometer. Notice how much of a hard time I have saying that. I can never get it right. So basically, I don't ever really say it except to, point it out. I started to write it over here, forgetting that it was typed there. But that's the blood pressure cuff. And so you can take that at either the brachial artery or the radial artery that we can see here in those two pictures, okay? And so blood pressure is going to vary according to the cardiac cycle, looking at that, the P, the QRS, and the T wave, for example. So systolic pressure, that's going to be the maximum pressure when the ventricles contract. And then diastolic pressure is going to be the minimum pressure when the ventricles relax. And so diastolic is always written over systolic. I'm sorry, I just said that totally backwards. Systolic pressure is written over the diastolic pressure. So when you tend to hear that average or normal blood pressure is 120/80, that's what's considered normal. Your textbook talks about the fact that optimal blood pressure for an adult is 110/70. And so we're going to get into this way less than we could in the grand scheme of things. You've got a little table here that gives some different age breakdowns that you can see there, okay? And then, oh, and I didn't mention this, sorry. The alternation between the systolic, the high pressure, and then the diastolic, the low pressure, that's what we would call a pulse, okay? The alternation between those. So just real quickly on this particular slide, there are lots of different diagrams about blood pressure out there. But we can see what would be considered our normal here with that blue line, okay, 120/80. And again, your textbook talks about 110/70 being optimal. And then this one shows this in a little bit different way. You can't even read the words on that one, I'm just now realizing. But notice we've got like low blood pressure, low normal, then we've got high blood pressure. Some people's blood pressure, like mine, tends to run really low, mainly just because I'm really active. People that are obese, have high cholesterol, are not active. Those people tend to have higher blood pressure. Your textbook, I'm looking at this right now, your textbook talks about several factors that play a role in blood pressure, talks about calculating your basal metabolic rate or your BMI, and that playing a role, talks about cholesterol some, and there's, again, just lots of different factors, genetic factors as well. But just real quick, before we talk about some things that play a role with this. So if somebody has high blood pressure, that's where you might have heard the word hypertension. And then over time, that high blood pressure is going to cause damage to the heart and to the blood vessels. It just stretches them more. I've got a video that hopefully we're going to be able to watch. It's going to highlight somebody who's got high blood pressure and that ends up having a heart attack. All right, so let's look at the factors that are going to impact blood pressure. So the first one is cardiac output, which by definition is the amount of blood that's pumped out of the left ventricle, since that's your really muscular side of the heart that's going to pump blood to the body through the aorta. So pumped out of the left ventricle per minute. This is calculated by multiplying the stroke volume times the heart rate to get the cardiac output. Okay, so stroke volume, by definition, it's the volume of blood that's pumped from one ventricle with each beat. Okay. And so it's going to increase with increased force of ventricular contraction. So the harder the ventricle contracts, the higher the stroke volume is going to be. And then heart rate, that's the number of beats per minute, okay, the number of contractions per minute. So you've got an example here that you have stroke volume of 70 milliliters and the heart rate's 80 beats per minute. Then the cardiac output, 70 times 80 gives you 5,600 milliliters per minute. Sometimes that's also converted to liters, and that's 5.6 liters per minute for the cardiac output. Okay. Notice it says cardiac output, again, affects blood pressure. It says if either stroke volume or heart rate increases, then cardiac output is going to increase. Therefore, blood pressure is going to increase. So cardiac output and blood pressure are directly proportional. Okay, so that if we have an increase in any one of these, we're going to have an increase in blood pressure overall. So for example, real quick, like if you're exercising, then your stroke volume and your heart rate, okay, are both going to increase. Your heart's going to beat more times per minute, okay, to deliver more oxygen and nutrients to the tissues of your body. And then the ventricles are going to contract more forcefully. So that's going to increase your blood pressure during exercise. All right, so then blood volume is going to impact blood pressure. So this is the combined volume of blood cells and plasma, the liquid portion of the blood again. Your blood volume and blood pressure are again directly proportional. right? So for example, if you have a decrease in blood volume, that's going to decrease blood pressure. So let's say, for example, that you're dehydrated. Then you don't have as much water in your blood as you should. And so as a result of that, that's going to decrease your blood volume. Your blood vessels are going to constrict when there's less blood in the vessels, and that's going to decrease your blood pressure. So this is one of the things that we will, again, tie back to urinary system function. And while I'm on this one, I'll mention that the plan right now is for you to have an assignment where you're going to address a lot of these factors with some specific examples of, hey, this is the scenario that is taking place, and then you have to tell me, how that impacts blood pressure, okay? And then, hang on just a second, and we'll do peripheral. All right, so then the third factor that can impact blood pressure is peripheral resistance. That's a tongue twister for me too. So it says the friction between the blood and the walls of the blood vessel. That's what this is. Peripheral resistance and blood pressure are again directly related. So if you have peripheral resistance increase in your body, as in if the blood vessels constrict, okay, vasoconstriction, then blood pressure is going to increase. So one example of this, and this is really the only thing in your textbook that's talked about with this, is that if you have fatty plaque that builds up in your arteries, then your blood has less diameter with which it can move, through which it can move. And so as a result of that, that's going to cause the peripheral resistance to increase. And that's going to then increase blood pressure. And then blood viscosity. So liquids can be really thick and viscous, or they can be really thin and watery and lack viscosity. So this is just the fluidity or the thickness of blood. So when there's high viscosity, that's going to increase peripheral resistance, and then again increase blood pressure. So we can kind of tie that back to blood volume, that if you're lacking some water in your blood, that's going to increase the viscosity of your blood and then therefore increase the blood pressure. All right, and then the final thing that's on here that can impact blood pressure are just various chemicals that people put into their bodies. So you've just got two examples here. So nicotine and alcohol. So nicotine, this is a vasoconstrictor, okay? It's a stimulant, and it's going to cause blood pressure to increase. And then alcohol is going to cause vasodilation. It's a depressant, and it's going to cause blood pressure to decrease. And then we'll look at some other chemicals and talk about some other chemicals as well. So real quick too, if you put a lot of these factors together as far as high blood pressure, peripheral resistance increasing, use of nicotine and alcohol, and fatty plaque buildup is what I was talking about as far as the peripheral resistance. And again, that could lead to a heart attack, that can lead to hardening of the arteries, atherosclerosis is what that's called. And then that being said, I just was going to mention the pages in your textbook that talk about some of the things that are pathologies about this. Just if you wanted to go ahead and tie those to these notes, if you listened to this before, we're really ready for that from an assignment. But diseases of the arteries start on page 399. They go through several different things on 399 and 400. On 401, they start talking about heart attacks, hypertension, stroke, and peripheral vascular disease are all on page 402. And the goal is that we're dealing with that in some other ways outside of the notes. We're just kind of scratching the surface here. Okay, and so then I'm going to mention these really quickly, just as a couple things to kind of think about with all the things with blood pressure that, again, hopefully we're going to get to some more details eventually. But that being said, when we're talking about vasoconstriction, again, blood vessels narrowing, diameter narrowing or vasodilation, blood vessels increasing in size or diameter. Okay, so when they constrict, that's going to make blood pressure increase. The blood's going to have a narrower diameter to travel through. When they dilate, then blood can move more freely because there's more space through which it can move. Okay, so a couple things. Typically, if you're stressed, your heart rate increases. That's going to increase oxygen and glucose delivery to the cells. So kind of the fight or flight response type thing with adrenaline, epinephrine, that if you're under stress, okay, or Martina running the marathon at the beginning of the year, that her adrenaline was pumping before that, and that increases the amount of oxygen and nutrients given to the cells. Hypertension, again, high blood pressure, then the heart's going to beat weakly because it's not getting what it needs, okay, in order for it to function, because blood's going to circulate poorly. When it's hot, your heart rate tends to increase. When it's cold, your heart rate tends to decrease. In general, if you stand up too quickly, your blood pressure drops. You may feel dizzy. Probably everybody's had that happen. It happened before. If you've ever fainted, that's when your blood pressure gets too low. Exercise is going to increase stroke volume. I mentioned that already. If you lose blood, that's going to decrease stroke volume. Okay, if somebody has a major injury where they're losing a lot of blood, for example, stroke volume is going to decrease if the heart rate is really rapid. So if your heart's beating really frequently, stroke volume is going to actually decrease as a result of that. If you have low iron levels in the blood, that's going to overall decrease heart function. In general, as females, we tend to have a faster heart rate than males do. You can see your different ranges there, about 72 to 80 beats per minute for females and 64 to 72 for males. And then when babies are in utero, their fetal heart rate tends to be about 140 to 160 beats per minute. Just a couple other things that we may or may not get to in great detail, but just to kind of tie that to the big overview of what we were just talking about. If you have any questions about any of this, let me know.